MATD 1534, we're still busy with quadratic inequalities and rational inequalities, that unit, and this is now a rational inequality, and this is our example 5. Now, here we have a fraction, already a fraction in factors form. So we do not need to work out anything here, do any other calculations. It's already done for us. So we can now just go and find our restrictions and our boundary points. Now, the restriction in a fraction is when you put the bottom equal to 0. So the restriction here will be x cannot be 5. And the boundary points is when we put the fraction equal to 0. I do not have to rewrite the fraction now because everything is done for me. As long as I show them, I'm busy working out the boundary points. And the boundary points in a fraction is when the top is 0. Because remember now, we're busy with equal to 0 when we do boundary points. When we do boundary points, we're busy with the equal to 0. And then for a fraction, that will be the numerator equal to 0. So therefore, the boundary points will just be x is minus 7, and also x can be 3. But remember now that we do not make a mistake here, that the equal to were not asked, so nothing will be inclusive here because there was not equal to ask. It's just greater than. It's not greater and equal to 0. It's just greater than. Okay, so we can go immediately to our number line, can put it, we can use it there, and then, right, so let's put on the number line. Let's go for the restriction first. It's negative 5. It's 5. So let's say 5 is over here. And of course, as we said, none is included here. So there's my restriction. And then my boundary point is 3, but it's also not inclusive. And then the minus 7, but it's also not inclusive. So this is giving us 1, 2, 3, 4 regions now. But now look what is going to happen now. And this is what I'm warning. If people do not do this method, this is what goes wrong. So let's start with a number. Let's say 6. Okay, I'm going to enter it here exactly as it is there. 6 plus 7. I'm just going to let the calculator do the hard work here. 6 minus 7, minus 3. 6 minus 3. Okay, close my bracket, come down. And then it is brackets x, and I was using 6, so 6 minus 5, close the brackets, squared. Okay, and remember now, I'm looking at greater than 0, so positive will be true and negative will be false, because I need to check for greater than 0. So positive will be true, negative will be false. This is 39, so this is true. It is greater than 0 there. Now, let's do 4, because 4 falls into region 2. All right, so I'm going to go back, and I'm going to just change my 6 to a 4. So it's 4 plus 7, right? And it's 4 minus 3, right? And it's 4 minus 5 squared. 4 minus 5 squared. I'm getting 11. And what is 11? 11 is greater than 0, and that is true again. So it's not true, false now, you see, for the people who don't check and decide it's true, false, true, false, true, false. You see, they're in trouble now. That's why I say rather check. Rather check. It doesn't take so long. Now let us get a number between minus 7 and 3. I'm going to take 0. I like always to take 0 for those. Okay, but now that is actually what I wanted to show. So for people, just decide, especially if they do that plus and minus, plus minus, plus minus, it is so dangerous to do that. So it's I need to do 0. Okay, sorry, I made a mistake here. So I need to do 0 plus 7. Okay. That we can actually easily work out because it's going to be negative 21 over 25. So it's going to be negative. So this is going to be true. And if I now do, I mean, this is going to be negative, which is false. False. And then I just need to do something less than it's minus 8, for instance. And that's going to be true again. I can see minus 8 gives me minus, and a minus is a positive over a positive. I'm going to get a positive. So yeah, we do not really need the calculator. We can actually be even quicker. But the point is rather just check that you see you are busy with the correct stuff here. So remember, we want positive to be true. So we want the true answers here. And now there's 3 regions that is true here. 3 regions that is true. And that is from negative infinity. So from negative infinity to minus 7, there's no inclusive here, as we said. And then the other region that's true is from 3 to 5. And then the other region that is true is from 5 to infinity. Because that 5 is not inclusive. If the 5 was inclusive, we could change that second region. But in this case, they did not ask equal to 0. So the 5 is out, forming 3 different regions here. So this concludes then the work for our rational inequalities.